Hi, I'm Edwin, and today we're going to talk about creative coding, live coding, and about OpenRNDR. I'm a creative coder. I'm also a partner of a studio called RNDR. It's a studio for interactive design based in the Netherlands. What we do is we make software-based design. So let's try to put that a bit into context with some videos. So what we see here is one of the very first things I made on my job as creative coder. I built a setup with a Kinect sensor and an iMac that plays the video of the powers of 10. And with the Kinect sensor, I essentially moved the playhead of the video further in time. So my position in space is somehow translated to the scales of the powers of 10, and it's a very nice experience. The sensor is really sensitive, so you can move just one centimeter on the tip of your toes, and you will move in those scales, and you can even move beyond the scales and go straight into the end titles. So what we see here is a work called Encode, and Encode is a two-folded piece. On one hand, it is an autonomous art piece that shows live video footage to users, to visitors in a very interactive way. So they can navigate through space and time using a sensor that's installed in the space. And on the other hand, it's a work that tries to explain its own material. And we do this by visualizing the data that goes into the work, the sensor data, visualizations of the state of the piece itself. And yeah, we really try to explain to visitors how these kind of works are made. So what we see here is an installation called Reflector. Reflector was made in collaboration for the International Documentation Festival in Amsterdam. And what makes this installation interesting is that it offers visitors the opportunity to create their own edit for a documentary film. The edit is made in real time using machine learning technology applied to an archive that holds 60 hours of unedited footage. A visitor can set parameters that change the tone of the edit, so dark versus light, the types of shots used, so long or close up, and they can also determine the pace of the edit, so should it be a slow or a dynamic edit. The editing process is shown as a visual decision tree. So while the edit plays, it is still making decisions on which shots to play next in the sequence. And when you are in the space where this installation is, you can actually look at these sequences and see why the machine learning algorithm will pick the next sequence. And these last two pieces that I showed, they're all made with our own tooling. The reason why we made it with our own tooling was simply because the existing tools didn't really fit our way of working. And basically, alongside building such installations, we also build a framework of tools for making such installations. And yeah, pretty much out of that, the OpenRNDR framework was born. I don't have so much time to talk about what OpenRNDR really is. To sum it up quickly, it's a framework for creative coding written in Kotlin, and it mostly works on the Java virtual machine. And we're going to jump into how to use OpenRNDR right now. So let's get started setting up our very first OpenRNDR project. And we do this from inside IntelliJ IDEA. And the best way to start is by checking out our OpenRNDR template repository from GitHub. So we get this here, and we place this in the demo directory. And then we hit clone. And as soon as the clone is finished, we have a project here. There's a README. We don't need that now. And on the left side here, we see the programs that are in this template. So let's check out the template program. So we have our template program here, and let's first try to run this to see what it does. Okay, so this demonstrates how to draw an image, how to draw text, and how to do a simple animation. So I'm going to strip out everything that I don't need here, just to write my own small little program. So we see an application block, a program block, and an extend block. The program block is all the code that's executed once a graphical environment has been set up, and it's only executed once. Everything that's inside this extend block is executed every time we draw on the screen. So we can start writing a very simple program, and all it does is set the background to pink. All right, we run it. Okay, so that's a pink background. Then we want to set the fill color. So everything that's related to drawing, for that we use the drawer object. So we can set the fill color on the drawer object. I can set it, for example, to white. And that means that everything we draw after it will be filled with the white color. Then we draw a circle, and we center it in the screen, and we give it a radius of 200. Instead of using these fixed coordinates, we can also use the mouse coordinates. So I use mouse.position here to use the mouse coordinates. So when I run this program now, we have the circle centered on the mouse cursor. Okay. The OpenRNDR drawer, it offers functionality to not only draw circles, of course, but you can also draw rectangles, lines, shapes, images, and text. And I will demonstrate a bit of those, not in this, in the old-fashioned way, but I'm going to demonstrate those in the live environment. Okay, so let's have a look at the live environment here, and we see that it's almost exactly the same as a normal OpenRNDR program, except for one small detail, and that is instead of having a program block, we have an olive program block. And let me run this program. And I also set up some things in the configuration here to make sure that the window opens at a convenient place. So the window here automatically opens right next to my editor. Now I write an extend block here, and to demonstrate that the program actually updates automatically, I'm going to turn the background into pink again. So we see that it now automatically updates. I don't have to rerun the program. The program keeps running, and we can now basically iteratively write our program. So let's start with something here. I'm going to create something that is called a contour. A contour is basically like a path or a curve, a shape. So we start by moving the pen to 0, 0, so the top left corner, and we give another instruction as line 2. Okay, so we make this contour here C, and we still want to be able to actually see it, so we draw it using drawer.contour. Right, so the moment I save the file here, we see this line appear on our screen. Okay, now I want to make this a bit more interesting, so I add a curve to, which adds a Bézier curve to our contour. So the first argument here is like a position for a control point. Let's make this like 100, 50, and let's move this to 200, 200. So we have now this curved shape and a line segment attached to it. Instead of line 2, we can use smooth to. No, sorry, that's called continue to make this shape less sharp, so nicely rounded. Then we can say continue to 300 and 100. No. Okay, well, this isn't the best of shapes, but this will do for now. Yeah, we see that the moment we close this contour, OpenRNDR draws it in a filled fashion. Actually, I don't really want to see that now, so I turn off the fill. Okay. Next thing I want to do is to draw this shape multiple times. So I write a for loop from 0 to 10, and I use something that's called draw.isolated, and that allows me to translate the shape for every iteration in the for loop, independently of all the other things I do with the drawer. So I write here 0 y times 40, and that should be 0.0. Okay, so now we have repetitions of the same shape in one direction, and now I add the other direction as well. And I type x times 80 here. Okay, so now we have a grid of this shape repeating, and what I would like to do now is to use this grid sort of as a basis for animations. So there is this thing, when we have a contour, we can get something that's called a subcontour. So if I write sub 0, 0 to 0.1, we get like roughly 1/10 of the contour. Right, so I can make this longer and I can make this shorter. Okay, so let's introduce something that's called O for offset. And we say that this offset is now equal to seconds, and I pass in O plus O. Right, so now we have a line animation. Let's make this a bit shorter. Going a bit too fast for me. Yeah, now all the copies are animating in exactly the same way. So let's try to spice it up a bit by introducing small variations. So in this calculation for the offset, let's try to include our for loop counters like this, and also add this one. So that's already an interesting sort of a line animation. Let's keep it at this. Okay, so we have seen that it's pretty easy to change the code of the program while it runs. We can change the animation, we can change the appearance of the animation. Basically, we can very easily iterate over our ideas while the program is running. I still think we can speed up this process just a bit more. And the way we're going to do that is by introducing a simple user interface that allows us to control many of the parameters of the program. So we start by adding something to the program that is called a GUI. So we make a GUI object, and then we install the GUI using extend. So the moment I'm saving this, we see the sidebar appear here. The sidebar is currently not populated, there's nothing in there, and that is because we haven't placed anything in there that is of use. So let's have a look here. We know that this 0.1, it controls the length of our lines, right? So if I change this, they become shorter. Now I would like to control these from the user interface. So what I do is I replace this 0.01 with settings.length. Now this one will not compile because settings doesn't exist yet. So I'm going to make a settings object. And inside the settings object, I will add a length property. And I'm going to annotate this length property with the double parameter annotation. And the double parameter annotation is basically used to inform the user interface generator what kind of settings to use for our length. It now knows that the length is of a type double, but it also requires to have something like a minimum and a maximum value. Okay. Still, we don't see settings in the sidebar here, but as soon as I write add to settings, sorry, that should be add to GUI, we have it. So now it's called no name. Let's give this a name, settings. And we have this slider here. And when I change the slider here, we see that our animation changes because the line length varies. Okay. Let's make these lines just a bit nicer. So I set drawer.line_cap to round, and I set line join also to round. And this will be visible when we make the lines a bit thicker. So we set the stroke weight to settings.weight. And we add that here to the settings as well. We just copy this double parameter, call this weight. And that has to go from at least 1 to say 20. And yeah, now we have really nice looking thick lines. Okay, we can hide this to see it in full effect. Let's change some more things. We can change this spacing here. So let's call this x space and settings.y space. And let's make those from 40. Great. Also, let's change the speed here. settings.speed. Okay. Okay, so the only thing left that we can change maybe is the color of the background and the colors of the lines. So let's set those two. So we set the stroke to settings.stroke, and we set the background to, sorry, we use settings.background here. So both of those things don't exist yet, so we add them. Far background, RGB pink. Yeah, it's called stroke. And those are annotated with something called color parameter. Okay, so we can change this one and this one. All right. A final thing I want to show here is that yeah, we have all these settings here, and we can actually save those settings. So let's call this one like session 0100.json, and I can change all these settings here to make a new composition. And I can decide, well, the previous one was better, so I loaded the old one back in. So it's a really nice tooling for quickly trying out ideas for animations and compositions, quickly adding a user interface to it, and being able to save and load the settings that you have found while experimenting with those with those parameters. Okay, let's ramp up this live coding environment just one bit more. I'm going to use something that is called the Composer framework, and with the Composer framework, you can organize your documents into layered documents. On each layer, you can draw animations, and you can prescribe how these layers interact with each other through blend modes. And you can also add post-processing effects to each layer. So let's just show how that is done. So I start creating a composite using the compose function, and I am going to write in my extend block that we want to draw this composite. Then inside the composite, I create a layer, and inside this layer, I give instructions for what to draw on that layer. So let's run this program. Right, so it still doesn't do anything at this point. Let's draw one circle. Okay, let's say that radius for this circle is going to be based on simplex noise. And we do this like this. So instead of using a fixed radius of 200, I now use an animated radius. I can make this go a bit faster. Right, so it's now a noisy radius. I'm going to just do the same thing for the X and the Y position. So I copy this. And I use seeds 1 and 2 for X and Y. And I replace here for X and Y here. And we have to still center this properly. Okay, and let's make this move just a bit farther out. Okay, so we have one layer that now animates, and we can have two layers, but the two layers now use the exact same seeds, so we're not going to see any difference between them. So I change the seed values here. I'm doing this all wrong. This has to be in a separate layer. Okay, so now we have two layers with two circles on there. Yeah, as I said, we can show how these how how these two layers, how we can change the interaction between the two layers. Because as it is now, it is exactly the same thing as just drawing two circles after each other. So let's first introduce a background layer. And on this background layer, I'm going to use a filter that generates a checkerboard pattern. So now the background looks like a chessboard. And then we want to change the blend mode. But I think it's better to change the colors of the circles first. So the first one, first one we're gonna draw in red, and this and the second one I'm going to draw in blue. Okay, now I changed the blend mode to multiply blend, and we see that now that the interaction between the two circles is that the color becomes black because the two colors are multiplied by each other. We also see that the blue circle applies, for the blue circle, also the multiply blend is applied with the chessboard. And actually, we don't want this. We can fix this by wrapping all of this up into another layer. So we have, we have layer grouping here. Okay. Now I want to show how to apply effects to the layers. So let's add a perturb effect here. This is one of the built-in effects. It's called perturb. And I would also like to change its settings. So we can actually inspect what settings this filter has here, but that is maybe a bit inconvenient. But we can introduce this GUI thing again. And we can add this thing to the GUI. And this is possible because the perturb effect has annotations built in. And this actually goes for almost all the filters that are inside OpenRNDR. So now we can just change settings of this filter here. For example, we can change some of its distortion settings, the amount of distortion, and the scale of it. Okay, let's do something about the colors. And this also shows that you can apply multiple filters onto a single layer, and also add this to the GUI. Color correction. So we can change the hue here, and let's also change the saturation a bit. Okay. Let's just add some more things. A Gaussian bloom, so that gives it a bit of a glow. See now everything is nice and glowy. Now we can change this a bit. And let's add some. Now, before we do the Gaussian bloom, I would also like to add a bit of a drop shadow and add it to the GUI too. So we see there's like a faint outline now, and we can change that a bit. Okay, it's a bit too much. Okay, now that we have all of that, I would like to add a fluid distort as well. So now we see that there's like it's actually a fake fluid simulation, but it distorts the image nicely. Okay, let's try to change this into some sort of simple poster design, for example. I can do this by adding another layer with another draw on it. Inside this layer, I will load a font, data fonts, and there's something called default.ttf, and let's try size 128. And what we're going to do here is first tell the drawer to use the font, then let's say for I in 0 until 10, drawer.text open RNDR, and that will be at x coordinate 200 and add, I don't know, 100 plus I times 50 maybe. Oh, let's space it out just a bit more. Oh. Let's have let's make this a bit more fun. Text, we can drop some characters from it. So let's set second based on the seconds and a cosine pulsar times text dot length divided by 2 plus text dot length divided by 2. Yeah, so we have sort of this this typing effect now. It's just like the same for every time we write it, but if we add I here, yeah, we get this nice little walking text effect. Spice this up a bit with some drop shadows. Ooh. Okay, change the blur window on it. All right, I still don't really like the colors, but we can change this a bit here. This is not bad. Well, let's also try to distort the text. Yeah, well, so that shows how you can make really nice layered compositions, and all while the program is running. I think this is really, really nice. To wrap it up, and if you're interested in trying this out yourself, you can go to our website, openrndr.org, on which you will find many examples and videos and links to starting points. The most important starting point, however, is the guide, which you can find on guide.openrndr.org, on which we try to explain from like the very beginnings to the most complicated topics in a very, very visual way. And if you just want to very quickly jumpstart into OpenRNDR and the live coding examples I've just shown, I can highly recommend to start from the OpenRNDR template that you can find on GitHub. So all you have to do is, how I've shown you before, check this out in IntelliJ IDEA, and you can immediately run the template program, and you're all set. Great, and thanks for having me.
Welcome to my session, Creative Machine Learning. My name is Andreas Refgaard, and I'm an interaction designer and creative coder from Copenhagen, Denmark. And today I have made a small website with some small fun activities that relates to simple machine learning that I would encourage you behind the screen to actually participate in. The URL is up here. So it's andreasref.github.io/SAT. So if you're up for it, you can try to join the website, open it maybe in Google Chrome, and then you can do the activities that I do. You can also choose to just sit back and enjoy me mess things up. Okay, so what are we gonna do? What are we gonna do, and what is ML5? So ML5.js is a library for doing simple machine learning tasks directly in the browser. And today we are going to do 3 small things, and I'll show you some kind of artistic things to build on top of these techniques. So the first thing we're going to do is to train a classification algorithm, something that you can train to recognize one class from another class. And then once we've done that, I'll show a bit more advanced example where I built a trainable camera feature on top of that. So we actually have a camera that we can teach when it should take a picture and when it shouldn't take a picture. After that, we're going to have a look at a network that has already been trained to classify 1,000 different categories. It's called MobileNet. It's not super accurate, but it's kind of fun. And there's a lot of fun in also some of the misclassifications that it can do. And then I'm going to show you a project I built on top of that called Poems About Things, where I try to generate weird poetry based on these classifications. So we can also have a look at that. And then finally, we will have a look at regression. So training a regression algorithm and then using the output, which the output are not like distinct classes A or B or banana or apple, but instead is a continuous value, a decimal number. You could think of it as a slider. And then we want to use that number to control something. And I have a couple of weird examples for outputs, like controlling the playback rate of a song or controlling how Mr. Bean moves. I encourage you, as I said, to try this along with me. The URL is up here, addressref.github.io. And because I can't really maybe debug for you just in advance, a few tips. Try to run these examples in Google Chrome. They will work in most other browsers as well. Try to allow the camera and the microphone, make sure you have permission to use them in the browser you're using. And then also allow it on a system preference level. And then I will also say that maybe if you're on a kind of old computer, some of it won't work. So you need to have a recently decent graphics card. But if you have a computer no less than 5 years old, it should work. This won't really work on most tablets or phones. So now you're warned. And if you want to read more about ML5.js, then there's a reference, but I'll get to that as well in a bit. Okay, so the URL is here, and I think let's just jump into it. So I'm going to open this first example called Webcam Classifier. And I'm building these examples by combining ML5 and P5.js, and I'm doing it online in this editor, the P5.js online editor. Let's just jump into it. Ignore the code and just press play and see what this crazy guy is doing. So this should hopefully prompt your webcam. You need to press allow. And then what you can do is that you can teach a model to distinguish between two different classes, class A and class B. And you do that simply by showing it something through the webcam and then clicking the A button, then showing it something else through the webcam and clicking the B button. So I want to show it A for me. I'm Andreas. And I'm going to give it some examples of me just sitting in front of the webcam. I'll try to give it a bit of variation so it knows that it's me even if I'm leaning back or leaning forward. And about 50 should be fine. Then I'm going to do the same, but for banana. So it will still kind of see me, but the banana will be in the foreground and closer to the camera. And with an equal amount of samples recorded, I'm going to hit the train button. And once it's done training, you can click Start Guessing. So now it's going to say A, and when I show it the banana, it's going to say B. A and B. So I taught it to distinguish between those two things. If you want to maybe make it output a more descriptive text, you can click the Stop button. Then you can go a bit down into the code and then simply change from A and B on line 32 and 35. And let's try to change it to Andreas and banana. Then we can run the sketch again. Then I need to record some examples again, but it's good practice. I'll do a lower number this time around. And click train. Click start guessing. So now I'll say A, and I'll say B. So what I would like you to do back home is actually to try this out. I also wrote it down here as a small exercise. Train a classifier to distinguish between two different classes and make the sketch output a descriptive text for each class. So again, what you need to do, you need to press play. You need to maybe do some examples of A and examples of B. I'm doing it with myself and a banana, but you could do it with whatever you got handy. Maybe it could be like you kind of close to the camera, you a bit further from the camera, you versus your hand, maybe your kid, maybe your dog, I don't know, maybe a chocolate bar, who knows? And then by default, it'll just say A and B, but you can also make it output a descriptive text by typing whatever name you have for the first class and whatever name you have for the second class. And then a cool thing about this is also, which I can mention maybe while you train this, is that you can actually save the model you made and then upload it later on. And that's kind of handy because then like you can actually embed this kind of functionality into a web page. Believe it or not, we're actually on the web, and this is just JavaScript. If you're interested maybe in like digging further into this, you can also have a look at what this project contains. So it contains a JavaScript file, but then also an HTML file that does very few things, but one of them is that it loads the ML5 library. So maybe while you do this small exercise, I'll show you a more advanced thing to do, but built on top of the same functionality, this binary classification where we classify class A and class B. We teach it the difference between A and B just on the fly. And that example is what I call Trainable Camera. I'm just gonna leave this sketch and I'll open the next sketch, Trainable Camera. And for anybody joining in, what we're doing right now is that I encourage you back home, if you feel like it, to go to this website and do these small exercises with me live. And we are now under one, train a classification algorithm. And I've gotten to the advanced example, Trainable Camera. Okay, so this, if you follow along from the beginning, this should look kind of familiar. We still have buttons for one class, button for another class, for training, and start getting. But now we also, the buttons are called something different. So this first button is not class A, it's actually the class that's where we teach it when not to take a picture. And I don't want this model to take a picture when it just sees me. That would be a bit boring. So I'm going to say, don't take a picture when it just sees me. And give it a bit of variation. But when it sees something slightly more interesting, maybe if this little dinosaur photobombs the picture, or photobombs the frame, then it should actually take a picture. So maybe you can bring in your cat or your kid, or I don't know. And again, roughly the same number of examples. Then I'm gonna hit train. And I'm gonna hit start guessing. And then it will go A, which is teach me when not to take a picture. So now it shouldn't take a picture. But let's see what happens if this dinosaur comes in the picture, tries to steal my thunder. Then it goes B, and then it actually takes a picture. And it saves the picture to my computer. So this is a somewhat functional conditional online photo booth that you can teach when to take pictures and when not to take pictures. Let me just try again. it took a picture. Okay, I'm gonna hit stop. And it's okay if you didn't do the trainable camera, but I hope at least some of you out there try to train your own classifier. What we're gonna do next is to have a look at this thing called ML5 MobileNet pre-trained classification. And I'm simply gonna run this first example. And just click play, and let's see what happens. So this is a model that has already been trained, and it's been trained on images of 1,000 categories from something called ImageNet. And in that particular instance of ImageNet, there's no categories for people. So it thinks that I'm all these weird things. It thinks I'm a syringe. Sometimes it can think I'm a microphone. I'm like a mask. I don't know. So it's not really good at detecting people. However, it's pretty decent at detecting objects, everyday objects. So let me just try to like not show myself, but maybe show more of this black background. And then what happens if I show it this? A banana. Oops. At least sometimes it thinks it's a banana. You can also put it on the table. Oops. Slug. Banana. Then I'm going to try to show it this, a little apple. And it kind of thinks it's a bauble or a Granny Smith. And let me try something else. Blow dryer, not really. Hairspray, yeah, not really. So it's not super accurate. Let's have a look at this thing. A cassette. Yeah, there you go. I want to show you a small little project I built with this. And it's called Poems About Things. And let's see if it works. This is one of the things I was kind of fearing leading up to this live performance, because sometimes this project actually breaks. But it uses the same model. And then you can have it take pictures of things and it will try to generate a poem about them. So let's see. Okay, banana, jellyfish, banana. And now it actually wrote somewhat of a poem about a banana. Is my banana too ripe? Is my banana bad? Is my banana tree dead? Is my banana tree cooked? Let's try one more thing, see if it wants to do something about, I don't know, this apple. Why are my Granny Smith apples turning red? It's a good question, not a question I can answer. Mine is still green. And maybe the last thing, let's see what it thinks of this, toilet tissue. Where are paper towels made? Oh, paper towel. I thought it was a paper towel. Let's try to do one more. I wanted to kind of generate something about toilet tissue. See if I can do that. Oh no, blood on my toilet tissue. My cat eats toilet tissue. Oh, okay. So maybe some of you are wondering, like, what is going on? What is he doing? So I'm building, what I did is that I built a project on top of this MobileNet classification model. So it is able to detect objects, and then I send that object plus a word or two, kind of like typical beginnings of search queries. It could be something like is, my, or does this, or where, can, or something like that. And then I send that to Google Suggest, Google Autocomplete API, which is the same thing as you do maybe from time to time when you try to search for something. So it tries to guess what you're searching for by completing your sentence, your search query, and it has different suggestions. And then I'm simply listing those because I find it to be kind of interesting and somewhat poetic at times. I'm going to show a few fun projects or poems that I did over the last couple of years with this project. This is a picture of a somewhat hairy chest, and because MobileNet doesn't have, or this instance at least, doesn't have a category for person, then it detects this as something it thinks is close, which is fur coat. And you could kind of argue that this is actually a fur coat, right? A human body, torso with hair, kind of like a fur coat. And then it asks, in my opinion, quite interesting questions. Is my fur coat real? Is it worth anything? Is it mink? I hope not. Is my coat fur? And so on. And then for some additional poems, there's some poems about bananas. Can they kill you? Can they be frozen? Can they cause diabetes? I don't know. But actually the things about banana trees being able to move and walk, I found out later on that they can do that. So in a way, this project is also a lens to see things through and make everyday objects a bit more weird or start asking questions about them. And then, some more poems that I like about refrigerators. Why can't you lay them down? Why can't the refrigerator cool a room, etc.? Or maybe this last one about organ donation. Because what is being detected is an organ, the musical instrument, but organ has multiple meanings. It can also be what's inside our bodies. And organ also happens to be the beginning of the word organization. So it makes these weird juxtapositions of questions about organ donation, organ failure, and more businessy questions about organizational structure and leadership and so on. Okay, so the exercise that I encourage you to do now is to try to place some different objects in front of the camera and try to observe as they get detected. What happens if you change the background or the angle of the webcam? And then you can also try my poem example if you feel like it and generate some weird poems. But I must warn you, like too many requests at the same time can make the API a bit cranky. So if it doesn't work, you can try again tomorrow. So I'm gonna drink a bit of water and maybe let you open the example and see what it thinks of you or thinks of objects close to you. And let's see how we're doing on time. Okay, so I think I have about 10 minutes left, and I will move on to the next little demo. And that is about training a regression algorithm. Because previously we've only looked at classification, and classification is really good for figuring out whether something belongs into a certain box. Is it a banana or is it an apple? Does it belong in class A or class B? But sometimes you don't want those distinct boxes. You're more interested in a continuous output. You're interested in kind of like a decimal number that can go between one range and another range, and it can assume all the positions in between. So it's kind of like a space you're exploring instead. Also think of it maybe in musical terms as a dial. So instead of like a button on a keyboard that selects which kind of sound you're using, sound 1, sound 2, sound 3, that could kind of be classification. Then what if you have a dial and you kind of want to control how much effect you add? For something like that, regression maybe makes more sense. And I will try to, I think, open this first example where I control the size of a rectangle with regression. So now you see that the interface has changed slightly. So instead of having buttons, now we have this slider, and the slider controls the rectangle size. So when I put it all the way to the right, the rectangle is pretty big. And when I put it to the left, it almost disappears. So what I think I want to do is try to see if I can train a relationship between how close I am to the camera and how big this rectangle is. So let's just see. If I move very close to the camera, the rectangle should be quite big. So I'm going to give it some examples of that. And if I move a bit away, it should be smaller. And this is actually not like, this has nothing to do with face tracking. It's looking at all the pixels, also the background of my apartment. And then if I move like far, far away, or maybe if I move a bit out of the picture, it should be smaller. Okay, so this is not super accurate. We're kind of just doing it on the fly. I'm gonna hit train. And then I'm gonna say start predicting. And I hope as I move close, it at least takes on relatively big values. And when I move away, it becomes smaller and smaller. So, and yeah, for this to be more like follow the movement more smoothly, I should have trained it a bit better, but I hope you get the idea. But maybe some of you get the idea and think, oh, it's really boring. Why did he show us that? Well, now I'm actually gonna take the output and have it control something a bit more interesting and a bit more playful. So I'll do the same thing with this next example, advanced example 1, playback rate camera. And we are in headline number 3, ML5, train a regression algorithm. And what I'm going to do now is have a song play in the background. And then the slider will control how fast the song plays. So when the slider is all the way to the right, it will play fast. If it's in the middle, it'll play at half speed. And if it's all the way to the left, it will almost stop entirely. Let's see how it works. If I move it to the left, it's very slow. If I move it to the right, it becomes fast. And then it becomes slower and slower. Okay, so what I want to do is kind of the same as before, but instead of moving my face, I think I will kind of tell it to stop by raising my hand. And the more I raise my hand, the more the song should stop, the more it should play at speed 0, meaning that it's actually not really playing. But when it just sees me, it should actually play at full speed. So I'm gonna train this. And sorry if the sound is really loud. I hope it's not too loud. But let me just train this and watch how I move the samples. Move the slider and also position my hand. That's kind of the relationship we're trying to train. And I have a thing in the chat. Let's just see, 5 minutes left. That's fine. Okay, so I'm gonna train it now. Let's have a look. And then slowly raising my hand. Raising it a bit more. And raising it even more. And maybe covering the whole thing with my hand. Let's see. Okay. Maybe it was a bit rough. Let's see. We're gonna get to go train. We are going to click start predicting. And let's see what happens if I raise my hand. So I can actually now control the playback speed with my hand. I think I need to train it a bit better in this position. So I'm going to add some more samples. performing pretty well. It's doing what I wanted to do, slow down fully when I show it my full hand. And then start playing. And stop again. Okay, so what I would like you to do is to also try to train this regressor and see if you can control maybe even either the sound playback or Mr. Bean through your webcam. The Mr. Bean example is very similar, but the output in this case is graphics. So you can see that it's actually gonna like control Mr. Bean, and maybe you can find a clever way of controlling Mr. Bean by moving your fingers. Like that could be kind of a fun little idea, or maybe you come up with something else. Let me just see the chat. We have 2 minutes left. So I am going to wrap up, maybe while you do this small exercise. And if anybody's just joining in and are thinking, what is going on? What is he doing? You can actually go to the website. I'll leave it up after I end this session in just a minute. And then you can visit it and try out these fun examples with using machine learning in quick and easy and hopefully kind of interesting ways. I also provided some links if you want to check out the library I'm using, ML5. And I am also actually right now doing a fellowship with ML5, so I'm trying to make even more fun, playful examples and templates for you to build interesting stuff on top of this. And I would also maybe say that you're always welcome to reach out to me. You can find my website down here and reach out on any platform if you have fun ideas or any questions, or maybe are interested in having a workshop or something like that. So yeah, I think that's it. I hope you enjoyed it. I hope it wasn't too fast or too weird or too boring or too simple. I don't know. I liked it, but it's strange new world of remote talks. So yeah, my name is Andreas Refgaard. Thanks for tuning in and stick around. More good stuff coming up.